For the final video in our equations week, we are going to continue to look at solving linear equations with variables on both sides, but with a little bit of a twist. Not all equations just have one solution. Some have an infinite or endless number of solutions, while other linear equations may actually have no possible answer. Make sure you have something to write with and something to write on, and let's dive a little deeper into solving some equations. In this video, we are still going to use DCIC as we work through today's question, the first question, and subsequent and additional questions. So let's apply this to this equation. I do not see any parentheses, so I'm going to skip my initial step of distributing, but I do see some like terms on the left side of my equation. So I'm going to combine the 2x and 3x to get 5x, which leaves me at 5x plus 8 equals 5x plus 8. This looks a little weird, doesn't it? We're left with the same exact thing on both sides of my equation. When you are solving an equation, and you ever notice at any point you have the exact same expression on the left side and the right side of the equal sign, you have stumbled upon an equation that has infinite number of solutions. This means that no matter what value you assign for x, the equation will end up being a true equation. In other words, when you check your answer, as you see happening and has been happening on the screen, you will constantly get both sides of the equation to equal the same value, no matter what you plug in for x. If we go even further within this equation and move on to step I, which deals with inverses, you would subtract 5x from both sides, leaving you with 8 equals 8. This further proves that this linear equation has infinite solutions, because 8 always equals 8 in mathematics no matter what. So this is infinitely or always true. Other examples that are slowly appearing on the screen also have infinite solutions. Infinite solution linear equations are easy to identify because all you're looking for is the exact same expression on both sides of the equal sign. At any point you notice this, you don't need to go any further. You don't need to keep solving the equation. You can immediately stop and state that the equation has an infinite number of solutions and move forward to solving additional equations. Now we're going to look at this second example. In DKIC, I have to start with distribution. This one does have distribution, so once I distribute, I'm going to be left with 2x plus 8 on the left side of my equation. I'm going to simply bring down the right side since there's no distribution present on that side of the equation. Moving on to C, there are no like terms that can be combined on either side of the equation, so I'm going to skip that step. Now I'm going to move on to using inverses, which is our I step. I want to get the variables to one side of the equation. In this case, I'm just going to decide to choose my left side as my variable side. So to accomplish this, I need to get rid of positive 2x from the right side by subtracting it from both sides of the equation. That leaves me with 4 equals 1. Now that doesn't make much sense either. And you may be thinking, what do I do now? Well, this is a false statement of mathematics, right? 4 does not equal 1, at least not on this planet. It never has, it never will be. Therefore, this linear equation is an example of an equation that has no actual solutions. This means no matter what value you plug in for x, the two sides of the equation will never equal to each other. You're never going to get the same thing. These equations actually cannot be solved. There is no solution, meaning no answer. Now, if you want a little hint on spotting no solution equations early, listen up to what I'm about to say. If your variable term on both sides of the equation are the exact same, but the constants, meaning the numbers without variables, are different, you're going to end up with an equation with no solutions. That is because your variable terms are basically going to cancel each other out, and you will be left with two constants that are never going to equal each other. Understanding that trick can save you quite a bit of time when solving certain equations with no solutions. All these examples that are showing up on your screen now also have no solutions. Notice, as I just mentioned, their variable terms are equivalent, but their constants are not. Therefore, all of them have no possible solutions. In this third and final example, we are going to work to solve this linear equation. I am going to start with D, distribution. Distributing the negative sign is the same as distributing a -1, which all that does is simply change the sign of each term inside of the parentheses to their opposites. So now that I have handled distribution, I can move on to combining like terms. -x and 3x combine to make 2x. So now my equation reads 2x minus 5 equals -x plus 16. I can now move on to using inverses, and I'm going to make the left side of my equation my variable side because I want to and I decided to. Therefore, I'm going to add x to both sides, resulting in an equation of 3x minus 5 equals 16. Next, I need to get rid of that -5 by adding 5 to both sides. Finally, I can divide out the coefficient of 3, leaving me with a solution of x equals 7. So this is a very similar example. It was covered in the previous video, and it's a kind of solution that you guys are used to seeing. And this is an example of an equation with one solution. So anytime you end up with x equals a number, a single constant, or any variable, whether it's x, y, z, w, doesn't matter, equals a single constant, this is one solution. All of the examples filling your screen now and the ones that were covered in the last video all had one solution. Most of the equations that you guys are familiar with dealing with up to this point do fall into that category of one solution. So after watching this video and then practicing using your flowchart, which you're going to do after this video, you should be able to not only solve these linear equations, but you should also be able to categorize them as having infinite, zero, or just one solution. As long as you stick to the foundations of DCIC, distributing, then combining, then using inverses, then checking your answer, when you are solving these linear equations, solutions become easier and easier to find. Practice makes it easy. Keep working hard and reach out as needed with any questions, concerns, or comments.